But Ibere, everyone wants an air conditioner and you're going to destroy this one? Do you really think an air conditioner in this condition is working properly? Would you buy an air conditioner like this, paying 10,000 Brazilian reals for one of these machines? But it doesn't cost 10,000 Brazilian reals. You get what I'm saying, right? Today we're going to see what's inside an air conditioner to finally understand how this thing works. Let's be honest, right? This thing here is noisy, takes up space in your house, is ugly, a pain to install, uses a ton of electricity, but it's everyone's dream on a summer day. Before we start opening up, well, I already started a little, but many people think the air conditioner is just this part inside the house. That you just screw this thing to the wall and cold air starts blowing. But no, the air conditioner is a couple that works together. This part stays outside making noise, heating up and using electricity, while the other is inside your house blowing cold air. So the air conditioner is both parts, and today we're going to open it and finally understand why this thing uses so much energy and is so complicated. Can I start? I can, right? Now that you've hammered it open, I'm curious too. Let's remove the white cover first then, okay? Oh my gosh, if someone used this air conditioner here, they'd get pneumonia or something like that. Humans have allergic reactions when the immune system treats a substance like pollen, dust, or mold as harmful. That's in the big biology book from Manuel do Mundo, which just came back from the printer and is already on sale. I'm leaving the link below. And yes, there will be launches in several cities. I'm listing the dates here on the side and we'll do it together with Mysteries of the Universe. If your air conditioner is that dirty, it's best to give it a little cleaning deal. The machine is already stripped down, but before we start removing its insides, let's physically understand the logic of the air conditioner. This here is your house wall, okay? So outside we have the noisy unit, which is called the condenser. And inside we have that cute little unit, which is the evaporator. Their names already give a clue about what's gonna happen. And inside the whole system, there's a gas that circulates between the two units called refrigerant gas. Let's start here, okay? The gas is at room temperature and enters a compressor that's outside your house. That compressor is what makes noise and uses electricity. If the bill is high, it's the compressor's fault. But at the same time, it's the heart of the system. So next, the gas comes out hot and compressed from the compressor. Then it starts going round and round and round and round to cool down. And how does it cool down? It cools down using the air outside. The air comes to the unit at room temperature, circulates around these little pipes, and comes out hot. That's why outside, if you put your face near the condenser, you'll notice it's blowing a lot of hot air. So, in the end, the refrigerant gas is practically at room temperature and begins to turn into a liquid. So, the function of the condenser, after all, is to take a gas that was at room temperature and turn it into a liquid that's also at room temperature. Turning a gas into a liquid is condensation. That's why it's called a condenser. Inside your house, over at the evaporator in the other unit, this liquid passes through your wall via a copper pipe until it gets to the other unit, the evaporator. And there it goes through a thin pipe we call a capillary tube and then enters a larger pipe. At that point, two things happen. First, decompression. The liquid was squeezed tight and suddenly it's released. And second, it's even more important for refrigeration, it changes from liquid to gas. These two things make the gas cold, just like what happens with deodorant. You can tell that it comes out super cold. So this cold gas keeps flowing around the coil inside. Why? Because the unit will take the warm air from your home and make it pass around this cold pipe. Then the warm air cools down and gets sent back into your living room. That's what makes the air cold. If the air is cooled, the refrigerant gas starts to heat up and then the cycle ends. It passes again through your wall and returns to the condenser and everything starts all over again. That's the theory. Do you think we'll find all that inside the machine? At least now it smells nice in here. Let's go! I'll try to follow the cycle more or less as I explained it on the board. So let's try to find the compressor inside the unit. Well, here we have a big pack of electronics that basically controls the motors inside. I was going to say it's not very exciting, but let's open it up, right? Yeah, not very exciting indeed. Here it is. This is the compressor. It comes with a wrap around it. I'm not really sure if it's to reduce heat or reduce noise. It's already quite different from a refrigerator compressor, which is chunkier and more sealed. Just so you know, this unit no longer has gas. It's already been emptied. Maybe the capillary tube I drew inside the evaporator is actually in this unit here, the condenser. I don't know how it works. Oh yeah, here it is. Looks like a sealed bottle, right? I don't know about you, but I feel like looking inside this thing. It's usually full of oil, and then it gets everything messy. Let's try to drain the oil.
Oops.
Let's move on to something a bit more radical here, shall we? It's been a while since I made a mess with an angle grinder in here. Now the oil decided to come out, huh? It was shy. Man, you can't see anything in here. We'll have to cut it in another direction. Open both sides and still can't understand anything. We'll have to open it sideways. And if you're using the angle grinder, don't forget to close the face shield. Got it? I mean, you didn't close it, right? Now I'm closing it. Oops. Of course, just making one cut won't open it, right? You'll need to make two. That's it. Wants to give me extra work. Two hours later, oh my goodness. Basically, this thing spins. Look, something spins here. What spins? I don't know about you, but I love these insides that turn into a big mess like this. There's something spinning off center here. Look, what a beauty. I'll admit, I don't exactly understand the path the air takes in here. But you can tell there's no piston. It kind of compresses the air and pushes it the other way. Well, not air, refrigerant gas, right? So the compressor is done. Let's try to find the coil that heats up. This one's not that hard to find, right? This here is the coil. This is where the hot gas passes through. It goes through these little pipes. From here, it doesn't look like pipes, but they are. Actually, we could cut it open to see, right? Shall we cut it? Aluminum in paste form on the grinder gets hot. Did the battery run out, or did I break the grinder? I told you I was going to show it's a pipe, but I can't see the pipe either. The aluminum got all crushed here. I didn't want to use the hacksaw. My goodness, it's impossible to see the little hole inside this aluminum plate. Could it not be perforated? It is perforated, and I'll prove it. Just missed the aim, right? Oh man. Come take a look at the little holes. This is what we were seeing from the outside. Inside it's full of tiny holes. The gas passes through here, but why all this? To maximize the contact area between the hot gas and the air so it cools down as quickly and efficiently as possible. That's why there are so many little pipes, and between the pipes there are tons of aluminum fins to dissipate the heat, very much like a car radiator. Speaking of which, on this side we have a fan that has the same function as a car radiator fan, which is to blow air through these aluminum fins. That deserves a like, doesn't it? So now we've found this coil and the fan. Their job is to take room temperature air and send warm air outside. Now let's move to the second phase, the evaporator, which is inside our house. To begin with, these little screens here are the air conditioner's filters. When the warm air from the room arrives, it passes through the filter before circulating inside the unit. That ensures there won't be dog hair and all kinds of junk floating around in your air. Well, ensures is kind of a strong word, right? It's important to clean this here, and it's not magic either. These pipes are arriving at the unit. One brings the gas in liquid state, and the other returns the gas already in gas state. Let's remove these covers here. Ooh. What a horrible thing. Wait, hold on. Whoa. Man, everyone's running out of battery today. Unbelievable. Hey. First of all, here's the brain of the unit. One important function we have here is the thermostat, a temperature sensor. That's why the air conditioner, when the room is already cold, will run more slowly or even shut off. It doesn't make sense to keep cooling the room, and the reverse is also true. If it gets too hot, it turns on. It's also here that it receives commands and processes them. If you want it louder, just the fan, etc. Let's be honest, in general, you need a whole separate course to use the air conditioner remote, right? We've now reached this coil here, where the refrigerant liquid finally gets really cold. And of course, we have to make the air pass through here and come out afterward. So the air will pass between these aluminum fins and be pushed by this piece that hasn't had a bath in about 400 years. I have to confess, it's extremely satisfying to keep bending these little plates here. I know they'll never go back to their original position, but that's okay because this air conditioner had no chance of working again anyway. Jansen, who's behind the camera, is complaining he can't clearly see the little pipes running inside here. Of course, that's just an excuse because he wants to see me make a mess. Here you go, Jansen. You wanted pipes? Here, enjoy. Got some cold air. The question is, how is that cold air going to be delivered into the room? After passing through this disgusting fan, there's a little flap at the front, which, in this case, was this part here, that moves back and forth to direct the air up, down, and spread it well around the space. There's a tiny motor. That little motor is what does the job. And the last detail I almost forgot to mention. When the air passes through here, it has a bit of moisture. There's a bit of water vapor hanging around. And this part is extremely cold. What do you think will happen? You guessed it. The same thing that happens to a beer bottle when you take it out of the fridge. The humidity in the air starts condensing around the bottle. The water that was in gas state turns back into liquid and starts dripping. And that's why the air conditioner drips, because the water starts to condense in that cold area. And now, yes, here at the bottom we have a water collector. You can notice that the water, as it flows through this part, carries away some of the impurities from the air that were just hanging around. So this part isn't very clean either. Here at the end, we have a hose that's precisely used to collect this water and carry it somewhere. Some part of the house where the water can be drained away. It stays in this position so the water can fall and the air outlet is right here. And here's the tip. It's not enough to just clean the filter. You should also clean this turbine here. I'd like to take this ending moment to thank Anderson, who kindly donated this air conditioner to us. We promised to return it, so he could maybe use some leftover parts, but I don't think he imagined we'd treat the air conditioner with so much love. After this video, maybe you're wondering, is there a way to not use the air conditioner? One time we tested something called the Indian air conditioner, made of brick with a fan. You can see the result by clicking on this video we're linking here in the suggestions, alright?